I've got an A and a B, and since I'm doing this a little out of kilter, I'm going to backtrack and show you something. So this heat of a reaction here, this is an exothermic reaction. And how do I know that? Because it's coming out negative. If it's an exothermic reaction, that means this amount of energy is being released from this reaction, meaning it's a product of this reaction. So another way to write an exothermic reaction is not put the negative, but actually put the number into the equation. And I'm going to go to another blank page too. So like, I'm going to do this. This is just a generic reaction. So one thing I could do, if I had the delta H, let's just say it's negative 20 kilojoules. This is exo, right? Exothermic because it's coming out negative. So this is one way I could write it. The other way I could write it is I could pick one side to put the 20 on. Because it's an exo, it would go on this side. And when you put it into the equation, there's no positive or negative, you're just putting it on a side. So if it's an exo, I'm putting it on the product side. This will be really important for some of the things we're going to be doing this semester. So if it had been like this, and it had been let's say a positive 30 kilojoules, that's an endo. So I would take this number and put it over here and make it as part of the reactants because it needs to go into the reaction. Here it is exiting the reaction. So if it's an endo, the amount of energy had to be put into the system. If it's an exo, it is being given off just as those products are being made. And the reason I'm putting that, reason I'm saying that is we're about to write this right here. So the positive and negative just means whether it's endothermic or exothermic. I'm going to write it in the equation. And the reason I'm going to do that is because now this big number is like a coefficient. And so in Gen Chem 1, we did this thing called stoichiometry. We're about to do a stoichiometry problem with energy. So we have 4.5 grams of oxygen, and I'm looking for heat. And heat is measured in kilojoules. So I'm going to start with 4.5 grams of oxygen. Oxygen is O2. And the first thing I'm going to do is convert it to the mole. Grams down to 1 mole of oxygen. This will be the molar mass. One of the things you have to know what to be able to do for Chem 1, from Chem 1 is how to convert to the mole. This would be 16 times 2 would be 32. That's the molar mass off the periodic table. That's from Chem 1. So when we did stoichiometry, see this is canceling. I brought mole of oxygen down, and I could have went to moles of CO2 or moles of water or moles of methane. I'm actually going to go to kilojoules, and so instead of being a mole-mole ratio, this is called a mole-kilojoule ratio here. And where the numbers are going to come from is the balanced equation. And so I'm going to put the 890.3 here. And I'm going to put in front of water, in front of the oxygen, the 2 there. This is the ratio. Yes, you could have just left that over there and know that that was going to be the ratio. Absolutely fine. Students sometimes put the negative in there. That would have been fine too. It would have been fine to keep the negative. The question says how much is released, and release means given off anyway. So you could have left the negative or you could have gotten rid of the negative. It doesn't matter. So 127.3 kilojoules released, given off. Or you could have put negative 1273.3 kilojoules. The negative means given off, release, exothermic. So I converted my grams to moles, and I used the not mole-mole ratio, but the mole-kilojoule ratio. Form of stoichiometry. Again, that 2 is not used up there. That 2 is used with a balanced equation. Anytime mole and gram are together, mole gets a 1. All right, look at this one. This time, I have been given my kilojoules of energy is released. And this time now I'm looking for grams of water. So I'm going to start out with 392 kilojoules. Now, if you want to make it negative, you can. If you make this guy negative, you're going to have to make the other guy negative because you can't get negative grams. So you can just ignore the negative. Negative just means it's released. So I can bring kilojoules down. Where am I going? Well, I'm going to use the moles of water. So instead of a mole-mole ratio, we have a mole-kilojoule ratio. Where do these numbers come from? Coming from our balanced equation. In front of water, there is a 2. In front of my kilojoules is the 890.3. All right. That's good, but I don't want moles of water, so I'll bring moles of water down, and I can go to grams of water. Now, anytime mole and grams are together, mole gets a 1. This would be the molar mass of water, 16 plus 2.02, so 18.02. We'll cancel, multiply, divide, and we get 15.9 grams of water. You can't make these negative because you don't get negative grams. If you want to take care of the negative, this would be negative because it says release, and that would be negative, and those two negatives would cancel. So you don't really need to worry about the negatives at all there.